So this is a particular kind of sequence in series called arithmetic. It looks like arithmetic, but you say arithmetic, like that. Probably you say arithmetic, like that. So an arithmetic sequence is a sequence, meaning ordered list of numbers, where the difference between consecutive terms is constant. Meaning if you subtract one term minus the term before it, you always get the same number. Right? If you get that number, if it's constant, that number is called the common difference, and the common difference is denoted with a d, lowercase d. So you see in the first list here, 1 to 3 to 5 to 7 to 9, terms are getting bigger, d is positive. Okay. In the second list, 9, 7, 5, 3, 1, terms are getting smaller, so you must be adding a negative number. d is negative 2. Good. Okay, so tell whether these sequences are arithmetic. And if they are, then state the common difference. Is the first one arithmetic? Okay, well, how do you check? Subtract, right? 1 minus negative 4 is 5. Right? That's 5, 5, 5, 5. So every time it's the same. So you're going to say, yes, that's arithmetic. Right? d equals 5. How about the second one? Let's see. Subtract. 2, 4. Okay, so it's not constant. Not constant. Therefore, no. Not arithmetic. Which means you don't have to find d. There is no d. Try this one. Tell whether it's arithmetic. If it is, state the common difference. What'd you say? That's a yes. What was the common difference? Negative 3, right? Terms are getting smaller, therefore negative. So yes, d equals negative 3. So we have a formula. We don't need to be creative like we did on last night's homework to come up with these formulas. And, we've got a way to do it because it's arithmetic sequence. Let's see, right. So these are the formula sheets that we get for Algebra 2, which so far we haven't really used. We did quadratic formula, and that's it. But they have, down here is all the sequence and series stuff, right? You're not asked to memorize these formulas. You need to know how to use them. That's it, right? So I'll pass them out just so you start getting familiar with them. Get that out of your way.
Oh, we're past.
So. So. Two more. So this formula here is the first formula in the column that says arithmetic on the top. This is called the explicit formula for the nth term. Not to be confused with the next one underneath, which is the recursive formula. We'll talk about that one later. But, you know, if you're asked to find the formula for the nth term, that's the one they mean. Not the second one, but the first one. So let's look at this formula. The variables in this formula are a sub n and n, right? They're going to be in your formula. What does A1 represent? The first term, and the D we just said is common difference, right? So what you have to plug in for are A1 and D, and then simplify. So in any sequence, if you can figure out what is the A1 and what is the D, you come up with a formula. Right? So, for example, the A1 in the first one, 4. Right? What is the common difference? 5. I mean, I don't need to check because it said these are, we know these are arithmetic. So I would go to the formula. Let me write it down. AN equals A1 plus n minus 1 times D. Now I'm going to substitute. AN equals 4 plus n minus 1 times D, which is 5. And then I should simplify. AN equals 4 plus 5n minus 5. AN equals 5n minus 1. So just like we did in the homework last night, right? If it's got 5n, that's why it keeps going up by 5. And then this minus 1 is like an adjustment so that it starts at the right first term. And you should just, when you get to a formula like that, check it. Plug in a few values of n. Make sure you're getting what you expect. Like 5 times 1 minus 1, or 5 times 1 minus 1 is 4. 5 times 2 is 10 minus 1 is 9. Yeah, seems like it works. Okay, this one, we see the first term, obviously, is there. What is the common difference? Negative 8, right? Going down by 8. So let me plug in. AN equals 60 plus n minus 1 times negative 8. So AN equals 60 minus 8n plus 8. So AN 68 minus 8n. And just check a couple. If n is 1, I'll get 68 minus 8, which is 60. If n is 2, 68 minus 16, which is 52. So it seems like it's right. No. You mean whether it's negative 8n plus 68? Commutative property, right? Doesn't matter which order. Okay, so that's the explicit formula for the nth term of an arithmetic sequence. So try to do the same thing with that. Okay. So what's the common difference? Negative 4. So we should have had AN equals 17 plus n minus 1 times negative 4. Okay, 21 minus 4n. And again, I can check. If n equals 1, then I got 21 minus 4, 17. n equals 2, 21 minus 8, 13. And again, remember that if it's arithmetic, then the formula should look linear. It should be kind of like mx plus b, right? That is, there's your mx plus b. And how many points does it take to make a line? 2. So once I've verified 2 of these points, the rest of them are going to be right. But I always would plug in and just make sure that you're getting what you expect. Okay. Now this is where these problems can get a little trickier, right? Now that we're not given, we can't see the sequence. We're not been given the first term. We've not been given the common difference. But that's what I need to write this formula. What I do know is I know 2 different terms in the sequence, A7 and A16. So how could I use those to figure out either the first term or the common difference? I mean, how do you go from the 7th term to the 8th term of an arithmetic sequence? You add D, right? How do you go from the 7th term to the 16th term? You add D how many times? 9 times to go from the 7th to the 16th term. So actually we can, using these 2, we've got a way to figure the D directly, right? So it should be that the 7th term plus 9 times the common difference, D, equals the 16th term. Okay. Well, I know A7 is 26, so I can substitute for that, and A16 is 71. Okay, now I've got an equation which is one variable, so I can solve for that variable. That's the D. So subtract 26, divide by 9, D is 5. Okay. Now, how can I know the D, how am I going to find the first term now? Yeah, I mean, you could, if you add D to get to the next term, how do you go to the term before it? You subtract it, right? So you could just go at that A7 and subtract D how many times? 6 times, right? Or you could set up another equation like this. You could say A1, which is the thing I don't know, plus 6 times the common difference is A7. A1 is going to be the unknown here. We know D now, that's 5. And A7 is 26. So solve for A1. A1 plus 30 equals 26. A1 equals -4. Right. So here's our formula for the nth term. AN equals -4 plus n minus 1 times 5. Right. AN equals -4 plus 5n minus 5, and I'm going to go straight across, 5n minus 9. So does it work? 5 times 1 minus 9 is -4. Okay, well we shouldn't check there. We should check with A7 and A16. If we put in 7, 5 times 7 is 35, minus 9, 26. 5 times 16 is 80, minus 9, 71. So it works. So you got to look for this difference in subscripts, to figure out this kind of problem. Okay, we also have a formula for the sum of an arithmetic sequence, also known as a series. So that's the third one down in that column. So, the capital S, that's for sum. I mean, that's how you know when you're looking at these formulas here, which ones are for sums and which ones are for the nth term. When the nth terms are A sub n, the sums are capital S's. Right. In fact, there is a term for this. I mean, you can't add up an infinite number of terms in an arithmetic sequence, because every time you add another number, you just change the sum. But when you add up some subset of those terms, it's called the nth partial sum. So in any case, this is the sum. The n here is the number of terms. What does A1 represent? The first term. And AN now is going to be the last term, right? If I say find S20, that means A20 is the last term. So again, the things that we plug into this formula, right, that's the number of terms that's the first term. And that is the last term. Now there's a story of a famous mathematician, 1800s. His name was Gauss. Right, Gauss. Another one of my boring stories, right? And the story is what they would call apocryphal. Do you know what apocryphal is? Anybody? Come on, you English wizards. Apocryphal means the story may not be true, but it's kind of like to make a point, right? Kind of like I was listening on the way into school today. I was listening to a podcast, and they're talking about this new movie, which is called The Founder. Does anybody hear about that movie? Maybe it's not out here locally yet, but by The Founder, they're talking about the restaurant McDonald's. And McDonald's was started by two brothers named McDonald, right, in Southern California. But then this guy comes along named Ray Kroc, and he kind of, he thinks all they've got is like one restaurant, but he sees the potential for this to become a huge deal, and this was like in the 50s when, things were changing. I mean, we were building the interstate highways. People were wanting to, be able to eat on the road and things like that. So fast food was just new, right? And this is like the start of it. So Ray Kroc eventually kind of maneuvers himself to be like the real leader, not these two guys with the one restaurant in Southern California. So they said there's this story about Ray Kroc that when finally he's built McDonald's into this big chain of things, and they still have their little restaurant in Southern California, that when he got control of that restaurant, that he literally got in a bulldozer and drove over that last restaurant. But that was not a true story. That's the kind of apocryphal thing. What he really did is he opened up one of his McDonald's right across the street, and he drove them out of business. Okay, so an apocryphal story. You're going to hear that word, believe me, in other classes and things like that. But apocryphal means it may not be a true story, but it's told all the time, kind of just to make the point. So the story about Gauss is that he was like a little kid, maybe he's a second grader or something, in Germany. That's where a lot of these famous guys came from. And the teacher, just to keep these kids quiet for a while, says, I want you to add up all of the numbers from 1 to 100, right? Plus 99, plus 100. He thinks these kids with their math skills, that'll take them an hour or so, give them time to go have a beer, whatever they do in Germany, right, on their breaks. But Gauss, the little kid Gauss, he goes, what would I get if I added up the first number times plus the last number? What do I get? Okay, what do I get if I add up the 2 and the 99? 101. What if I do the 3 and the 98? Every time, okay? So for every pair of these numbers, you add them up, you get 101. So how many times 101 are you going to get? 50, right? So the 50 is the number of terms divided by 2 right there, right? Times the first term plus the last term. So that's exactly what he did. 50 times 101, right, is 50, 50. So the teacher had to find something else for Gauss to do. Because he was done. Yeah. Oh, he was a brilliant guy. He's like, one of the guys, I get him confused sometimes. One is Gauss and the other one is Euler, E-U-L-E-R, that are like the most prolific. They produce the most stuff of any mathematicians ever. Gauss. So anyways, let's try evaluate the series. Is this someone who wanted to do? Yeah. Okay. So evaluate the series. It's in summation notation. Yes, you have a calculator to do it, but be prepared that you may be, the test will say, do it, show the formula, use the formula, or take your calculator away. So we want to feed this formula, Sn equals n over 2 times a1 plus an. Okay, first thing, how many terms are there in the sequence? 20. It starts at 1, ends at 20, so the n equals 20. Okay. Okay, how do you find the first term when you're given the summation notation like that? You plug in the lower limit for n, right? So the a1 in this case is going to be 3 times 1 plus 5 is 8. Okay, and then how do you find the last term? In this case, it's going to be a20. You plug in 20 right there. So I get 3 times 20 plus 5 is 65. Okay, so now we plug all this in our formula. S20, the sum of the 20 terms, is going to be 20 divided by 2 times 8 plus 65. So S20 equals 10 times 73, 730. Okay, so try to do the same thing with that one. Everybody get those three numbers? So S12 equals 12 over 2 times 9 plus 86. No, that's 730. 570. 570. Okay. So now, what if you have to add up? What if you have to add up something like this, where you can see that it says the first 20, it's an infinite series, right? Because it goes dot, dot, dot. But it says only add up the first 20. So this would be called the 20th partial sum, right? So it just gives the first 20 terms. What can you tell by looking at this sequence? You could tell the first term. You could tell the common difference. You know the number of terms. You can see a common difference, but you don't know the last term, right? So how are you going to use the formula if you don't know the last term? Go ahead. No? No? So again, I need to feed this formula. Sn equals n over 2 times a1 plus an. How do I find that last term? In this case, the a20. Well, you could just use the formula for an, right? There's a formula for an. That would be a1 plus n minus 1 times d. I don't really need the formula. I just need to get the what's a20. So I plug in 20, plug in the first term of 8. It's the 20th term, so it'll be 20 minus 1, and the d is 3. I can tell that much. So a20 is 8 plus, that'll be 19 times 3, which is 57. So a20 is 65. Okay, so now I can use this formula. S20 equals 20 over 2 times 8 plus 65. And that'll give us 10. This is the same one we did 2 slides ago. 10 times 73 is 730. So if you don't know the last term, you got to find the last term. Or, actually you have an option, and that is you could always just like incorporate the formula for an into the formula for the sum, right? So in place of the an, you put all that right there, and then you can simplify it a little bit too, because there's two a1s, and now you've got a formula that you don't need to know the last term anymore, and that is the last formula in that column there. That's why that formula on the bottom is there. If you have to find a sum but you don't know the last term, then use that, right? In this one, you just need to know number of terms, first term, common difference. And that we could tell. So you don't have to use that formula, but that's what it's there for. And like I said, you get this on the test. So I would use it. So let's try to do that. Try to use that last formula with this series. Okay, so here's using the second formula. N over 2 times 2 times A1 plus N minus 1 times D. So it looks like the N is 15, that's given. The first term is 9, that's in front of us. And the common difference is 7. So that's all you've got to plug in. S15 equals 15 over 2 times 2 times 9 plus 15 minus 1 times 7. And do all that at 870. Okay, recursive. So this is the second formula in that column, right? It's called recursive. It means that the value of one term depends on the value of a previous term. Now, we saw a recursive formula before in this class. Anybody remember when we saw it? It was watching a movie, watching that video. What was the sequence that they described in there? Right at the beginning, right when Mario Livio is like drawing on a deck outside. Fibonacci sequence, right? So a Fibonacci sequence goes like this, right? You write down 1 and 1, right, are the first two terms. And then the next terms, after you've got the first two terms there, you keep adding the two terms before it to get the next term. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, right? 8. That's a Fibonacci sequence. So the first thing you've got to do is you've got to say A1 equals 1, A2 equals 1, and then AN equals AN minus 1 plus AN minus 2. So when you use these like subscripts of N minus 1, N minus 2, I mean, that's just telling you like relative position. AN minus 1 is the term right before AN. What would be the term right after AN? AN plus 1, right? So as a subscript, that's just trying to tell you like in order. This is the term right before it, right? In the Fibonacci sequence, it's telling you for any term in the Fibonacci sequence, you add up the term right before it and the term right before that. That's just how you'd say it. But before you can get started, you got to know what those first two terms are, or else you would never get started, right? So when we write a recursive formula for one of these arithmetic sequences, it's not enough just to like fill that in. You've got to like say, what's the first term? Otherwise it can't get started. Okay, but this kind of makes sense. It's just saying, if I want to find the nth term in an arithmetic sequence, I'll take the term before it and I'll add the common difference. Seems like it's what we do, right? We just keep adding that same number to get the next term. I mean, I find that students have trouble with this sometimes. They have trouble with the subscripts. You know, the n minus 1, n plus 1 kind of stuff. But that's why, we need to at least put it up there. So write the first 6 terms of this sequence. If A1 is 1 and AN is AN minus 1 plus 4, right, then A2 should be A1 plus 4. So that is 1 plus 4 equals 5. Right? A3 should equal A2 plus 4, right? Which will be 5 plus 4, which is 9. Right? A4, I'll do one more, is A3 plus 4, which is 9 plus 4, 13. So we see the pattern. A5 is 17, 21. I mean, you usually don't think of arithmetic sequences like the difference of consecutive terms, right? You usually in your mind, when you look at that, you say, it looks like we keep adding the same number to get to the next term. So you're really doing this kind of recursive thinking. You just keep adding that same number, right, to get to the next term. That's all this is doing. Right, so try to do this one. Write the first 6 terms of that sequence, right? Looks like the first term is 3. And what's the common difference? Negative 7. So what is A2? Right, A3? Negative 11. A4? A5? So next, write the recursive formula for that sequence. Actually, that was supposed to be mine. It's okay. Just make this one. You doing it? I mean, what's the only thing you got to plug into the recursive formula? The D, right? What is the D? 10, right? So that's 10. D equals 10. So we have to say AN equals AN minus 1 plus 10, right? Any term equals the term before it plus 10. Now, I got to start it, right? I mean, if all I knew was that right there, I would not know that that's my sequence. So what's the last piece of this? I got to say what A1 equals. A1 is 3. Okay, now I could generate that sequence. Right? Give it the starting point, and then give it that recursive formula. Okay, so do the same thing for this one. Oops, that needs to go off. And then that's the end. So what is it? AN equals AN minus 1 minus 6. And A1 equals 19. So altogether, you could generate that sequence. And there's the homework. Right? You got plenty of time to start on this, right? Don't waste our time.
Sure.